Welcome to this UPmaths video where I'm going to be looking at approaches to integration for approximately, if you're like 17, sort of second year of A level if you're in Britain. This is my approach. It's quite talky. I don't have very many talky videos. Usually it's just lots of examples. I've got this because I know some people just like to kind of get the big picture explained, and sometimes talking is a nice way of doing it. And this will tell you all about my approach to integration questions. Let's get on with it. I've kind of got a four-stage process. So stage one is I go, is it really easy? Am I just trying to integrate x to the n, or 1 over x, or e to the x, or sine x, or cos x? I'm always looking out for that because they're really easy. That's what most people start off doing when they're integrating. The second thing I ask is, so number 2, is it on the formula sheet? You'll have noticed the word simplify kicking around. We'll be thinking about that in a minute. Is it on the formula sheet? I know that some people don't use the formula sheet. I tend to because it just means I have to remember things. But depends on your learning style, you might actually remember them, in which case 1 and 2 might be kind of combined in your mind. The next thing is the top the differential of the bottom? If so, it's going to be an lnx type question. And you might have learnt to use a substitution in this case, the substitution being the thing on the bottom. If it's none of those things, my general rule of thumb is, well, it's going to have to be, well, I've either made a mistake or it's parts or substitution. My rule of thumb is it's going to be a substitution if I can see something that's kind of inside something, because generally you substitute inside. And parts, it's usually parts if there's something you want to get rid of, so you either integrate or differentiate it away. Finally, before I do some examples, because I'm going to do some very quick examples here, simplify. I kind of just try and integrate it straight away, but at the same time I'm thinking about simplifying. It's funny because for some things I have this really strict method, and if you follow the steps like a computer program it always works. With integration I find it's a bit weirder because there's the whole, do I simplify or not? If I'm going to simplify, how am I going to simplify? And the thing is, you're trying to take it in a direction of something you can integrate. So, and I've written trig, indices and logs as the 3 classic things that we use to simplify, but there's other things that we can do as well. Right, so let's do some examples. What if the question is integral of 1 over x cubed dx? Well, we could use our indices knowledge, and we could say, well, that's just the same as the integral of x to the minus 3 dx, and then we look at this and we go, oh, do you know what? That's x to the n, type 1, easy. If you hadn't spotted the indices thing straight away, you might have tried 1, then 2, then 3, then 4. If none of those fail, you then go, can I simplify it? You spot the indices, and then it solves itself. Let's look at another example. What if it's integral of cos x dx? Well, straight away we spot it's just cos x. Ta-da! What if it's the integral of 5x e to the x squared dx? I'm just going to rattle through. This is not how I normally do examples. I normally give you time to work it out, and then I do lots of talking and show you my working. Less talking, more working. Anyway, this is just a talky one. So while I was waffling on there, maybe you've had a look. Well, it's clearly not a simple one like that. It's not on the formula sheet. There's not a top and a bottom. I'm vaguely starting to just in the back of my mind wonder about simplifying, but not yet. I'm going to go, is it parts of substitution? Substitution is if there's something inside. So let's try substitution. Oh look, that's inside because it's kind of inside the exponential. And the rule of thumb I use is, what if I differentiate that? What am I going to get? Because when you do substitution, you end up with the differential cancelling often. Oh look, that would eventually cancel with that. It's a substitution question. Brilliant. Let's look at another example. This is one of the ones where I look at it and go, yeah, I don't think you're going to simplify anything. Because it's quite simple already. Some people make the mistake, especially early doors of just learning some of this more advanced integrations, and go, oh, there's a sine x. No, you can't do that. And the reason you can't do that is because there's an x attached as well. So we cannot use, it's not a simple one. It's not on the formula sheet. There's clearly not a top and a bottom that differentiate, blah, blah, blah. So it's a substitution or parts. My gut feeling, the way I would do this, I'd go, well, there's nothing inside. So is it parts? Well, if it was parts, I'd split it up into two things, so an x and a sine x. Can I make one of them disappear? Yes, I could. I could differentiate x to make it disappear, because it would just become 1. In which case, can I integrate sine x? Yes, I can. It's a type 1, which I've scribbled out. Anyway, but yeah, so that would work. So I'd do parts, and then it should work okay. Let's do another one. What if it's the integral of 1 over x dx? I'm going to do it slightly backwards. I could use my indices to simplify that, so I'm going to make that integral of x to the minus 1 dx. And then I'm going to go, is it a type 1? It is a type 1, it's really simple. And then as I'm starting to answer it, I go, oh, I've got to be careful, that's actually 1 over x. So it's just ln x. Stick a plus in. And you might put modular signs, let's just not worry about that, because that's for another time. So the mistake some people make is they go x to the minus 1, it's like x to the n. It's not a special case. When it says x to the n, what that should actually say is x to the n, brackets, n not equal to minus 1. Let's do another one. What if it's the integral, while I'm writing this, see if you can spot what it is, 10x plus 7x to the 6 divided by 5x squared plus x to the 7 dx. Right, it's not a simple one, it's not on the formula sheet. Oh look, the top's the differential to the bottom. You might just do this straight away and just say, oh, it's ln of 5x squared plus x to the 7. And you might, again, we're not worrying about modular signs. Or, depending on how you've learnt it, you might now do a substitution. Because what you do, what might happen is you might not spot. You might go, oh, no, I can't see that it's type 3. I'll try a substitution. So then you go, well, what's inside? And if that is your normal approach, that you don't spot the logs but you use substitution, you'll probably be in the habit of making u equal to the bottom of the fraction. And if you do that, you should be on to a winner. Let's try another one. Integral of sine to the 7x. This one is very easy. By the way, that's a cos. I've written quite badly. This is very easy if you spot something. This is another one that takes a while to get used to. I'm pausing for thinking time. So, that actually means this. Sine x to the power 7 cos x. That's what that 7 means. That 7 in there is a shorthand. It's just saving us from writing brackets. There is an argument for not doing this at this stage of learning maths, because it kind of overcomplicates things, but there's an argument for doing it as well, because then you're used to the terminology. Hey. Anyway, oh look, it's not simple, it's not on the formula sheet, top isn't differential at the bottom, although remember you can kind of ignore this method anyway. I just like to include it because it makes it easier. So it's either parts or substitution. Oh look, it's probably substitution because there's something inside. And if you put u equals sine x, it will work because that differentiates to cos x, which then means eventually, if you do the working, remember we're doing no working here, this is just an introductory chatty video, the cos x would eventually cancel. Let's just do one more, because there's just one other aspect I want to highlight. There's something on here I haven't used, so you might spot what this actually is about. Sine x cos x dx. Personally, I often find this kind of question quite difficult. But there's things I do to kind of stay clear and make it easier. Right, it's not an easy one. Again, there's a mistake here. You might go, oh, there's a sine and a cos, but you can't, because you can't separate them. So it's two things stuck together, and box 1 only has things on their own. It's not on the formula sheet, although you might have spotted it on the formula sheet, which is fair enough. Maybe that's how you think about it, but let's pretend we haven't spotted it. Because anyway, bear with me. It's not one thing divided by the other. Now, parts, I'm going to cross out parts, because in general, if it's just trig, parts doesn't work generally, because when you integrate something that's trig, you just end up with more trig. So it can work, but it's not always that great an approach. Substitution, the reason I would say I'm not going to use substitution here is there's nothing inside anything else. It's just something multiplied by something else. Oh, we've just gone all the way through the list and we haven't managed to solve it. That's why I want to do this last example. So this is for me, this is my approach. This is where I go, right, now I'm going to have a go at simplifying. Well, there's no logs, there's no indices, going to have to be trig. Oh, of course, and then we try and spot what it is. Oh, wait a second, sine 2x equals 2 sine x cos x. That's handy, which means that this becomes the integral. I'm going to stick a half outside because I like to do that with the numbers. Sine 2x dx, which you're probably comfortable integrating. And some people, I would personally even do this myself in an exam just to be absolutely sure, might put u equals 2x because that's inside, and then that would solve. Or you might just know what this is straight away. So thanks for watching that. This was a very talky video. Most of my videos use worked examples, so I think that's the best way to learn. But I think the best way to learn is to have a little bit of contrast in the learning, and sometimes people need that explanation of a topic, and this is one thing where I thought it would be useful. It would be great if you could subscribe to my YouTube channel. Help show your support for the free videos that I'm putting on YouTube. It'd be great if you could like this video. Just helps raise it up the search rankings. It also makes it easier for you to find things in the future to do with maths that I've made. And if you want to find out more about UPmaths, you're welcome to go to my website, drduncanjames.co.uk/UPmaths. There's lots of stuff on there, and if there's anything you can't find that you want, I am making stuff almost every day for UPmaths. And if I get a message from you with a request, there's a good chance I'll go, oh, I'll do that today. Hey, thanks for watching.